Peru. A civilization built a city older than the Egyptian pyramids here, without metal tools, without the wheel, without any writing system to pass knowledge between generations, without pottery, the technology archaeology consistently identifies as a prerequisite for organized urban construction at this scale. And yet the city exists, has existed for 5,000 years, larger than anything built in the ancient Americas at the time, larger than anything standing in Europe during the same period. For 7 decades after its discovery, the international academic community refused to accept it as genuine, not because the evidence was ambiguous, because if it was real, if the dating held, if the architecture was what it appeared to be, then everything written about how civilization developed in the Western Hemisphere was structurally wrong. This is not a story about what ancient Peru built. It is a story about what ancient Peru knew, how precisely they knew it, and why it required decades of institutional resistance before anyone with authority would admit they did. 7 places across Peru. 7 engineering achievements that solved problems formal science spent centuries trying to articulate. Consider what is waiting in this video. A hydraulic system powered entirely by wind, operational in one of the driest deserts on Earth for 1,500 years and still moving water today. An agricultural research facility carved into a mountainside that generated 17 distinct microclimates simultaneously, used to feed an empire of 12 million people across terrain so extreme that sustaining that population should have been impossible. A fortress whose entrance was engineered not for accessibility, but for lethality, designed so that an invading army of thousands would be funneled into a corridor wide enough for one person at a time. And a pyramid in the middle of a modern capital city, surrounded by concrete structures that have required reconstruction after successive earthquakes, still standing because 1,500 years ago its builders applied seismic engineering principles that structural scientists only formalized in the 20th century. 7 places, 7 moments where knowledge existed centuries before the civilizations we credit with discovering it. In every case, the question is not simply how they built it. The more uncomfortable question is why it took institutional science so long to say what it was looking at. 250 kilometers north of Lima, Soup Valley, 1994. Peruvian archaeologist Ruth Shady arrived at a site logged in survey records for decades, listed, catalogued, repeatedly passed over by researchers who looked at earth mounds rising from the valley floor and assumed natural formations. Shady began to excavate. Beneath those mounds, buried under centuries of wind-blown desert sediment, was monumental architecture. Stone platforms rising from deliberately leveled ground, sunken circular plazas, residential complexes organized along planned routes, an urban center covering 66 hectares of desert valley, built to a coherent design by people who clearly understood how to organize space for a large population. Radiocarbon dating of material recovered from the site produced a number that stopped the team. Construction at Caral began approximately 5,000 years ago, around 3000 BC, the same era as the earliest pyramid construction in Egypt, the same era as the first cities in Mesopotamia. What Caral shared with those civilizations in timing, it did not share in character. Across decades of excavation covering the entire site, researchers found no weapons, no fortifications, no evidence of organized violence, no mass grave sites, no defensive walls of any kind. A city of that age and scale, built without military infrastructure of any kind. The implications were significant enough to make the mainstream archaeological establishment deeply uncomfortable. Here was evidence that complex urban organization could develop without warfare as a catalyst, without military hierarchy as an organizing force, without conquest as a mechanism for expansion. If Caral was real, the dominant model of how civilization develops required revision not at the margins, but at its foundations. The academic response was not independent verification. For the better part of 3 decades, researchers questioned the dating methodology, questioned the architectural interpretations, questioned Shady's conclusions at every stage. Funding was difficult to secure. The site received a fraction of the attention that comparable discoveries in other regions generated almost immediately. Shady continued excavating. She continued submitting samples to independent laboratories. She continued presenting evidence that accumulated rather than diminished under sustained scrutiny. Caral is now a UNESCO World Heritage Site. The dating has been confirmed by independent laboratories on multiple continents. Ruth Shady spent 30 years of her professional career establishing that what she found was what it appeared to be. During those 30 years, the city was always there. The evidence was always present. The only thing that required 3 decades was the acknowledgement. From the oldest confirmed city in the Western Hemisphere, to a desert where someone engineered a water system that nobody understood for 1,500 years after it was built. Nazca, southern Peru. Annual precipitation here averages less than 4 millimeters per year. 4 millimeters. The Sahara Desert, the standard reference point for extreme aridity, receives approximately 25 millimeters annually. Nazca receives less than 1/6 of that. A complex civilization not only survived in this landscape, but sustained itself across centuries, not despite the absence of water, because they engineered a solution requiring precise knowledge of geology, hydrology, and atmospheric physics. Distributed across the Nazca Desert are 46 spiral formations cut into the earth at regular intervals, varying in diameter from 1 meter to 30 meters, positioned in chains corresponding to routes of underground aquifer systems beneath the desert floor. For generations, researchers identified these formations as irrigation access points, openings through which people could descend to maintain underground water channels. That interpretation was incorrect. In 2016, Rosa Lassaponara of Italy's National Research Council analyzed the Pucchios using satellite imaging. What the data revealed contradicted the access point interpretation entirely. The spirals are wind traps. Each formation is positioned and oriented to intercept prevailing wind at that location, shaped to funnel air downward into the aqueduct system below, creating pneumatic pressure that drives water horizontally through channels extending toward agricultural fields kilometers away. A system requiring simultaneous knowledge of desert wind patterns, underground water table topography, pressure physics, and channel gradient engineering, integrated into a single functional network. Lassaponara's findings describe the Pucchios as representing a sophisticated hydraulic system requiring a detailed knowledge of the hydrogeological characteristics of the area. Detailed knowledge, not approximate, not accumulated through trial and error over generations. Technically precise knowledge of how this specific underground water system responds to specific atmospheric inputs, acquired without geological survey instruments, without pressure calculation tools, without any technical apparatus that contemporary hydrological engineering depends on. Still moving water today. Lassaponara's team confirmed the system worked. They confirmed it had continued functioning without significant modification across 1.5 millennia. They could not identify the knowledge source from which the original engineers derived their understanding. That source remains an open question, from a desert hydraulic system that no one understood until satellites provided the answer, to a mountain laboratory operating on principles that agricultural science would not formalize for centuries. Sacred Valley, 3,500 meters above sea level, carved into a natural circular depression in the Andean plateau. Concentric terraces descending in rings toward a central floor. 7 rings, each one lower, smaller, and thermally distinct from the ring above and the ring below. 30 meters of elevation separate the outermost terrace from the center floor. That differential produces a temperature variation of approximately 15 degrees Celsius between top and bottom, measured simultaneously on the same day within the same contained space. Agricultural scientists studying the site confirmed what that gradient means in practice. Each terrace ring replicates the climatic conditions of a different Andean ecological zone. High-altitude tundra at the outermost ring. Temperate valley conditions at the center. 17 distinct growing environments within one structure, accessible within a single morning's walk. This is a controlled experimental facility, designed to expose crops to the full range of Andean conditions simultaneously, to identify which varieties survived at which altitudes, to develop hybrid strains capable of growing where food production would otherwise fail, to test cultivation techniques across climate zones without establishing separate farms across hundreds of kilometers of vertical landscape. The Inca Empire sustained an estimated 12 million people across terrain spanning sea level to above 5,000 meters, feeding that population consistently, without refrigerated transport, without contemporary seed science, without the agricultural methodology that European civilization developed only in the 18th and 19th centuries, required botanical and climatic knowledge that Moray represents in physical form. A research station operating centuries before controlled experimental methodology was formalized anywhere in the Western intellectual tradition. No documentation of its design principles has survived. No construction records, no engineering drawings, no written account of the knowledge from which the design was derived. The structure remains, still generating those 17 environments within its rings, still doing what it was built to do, from a laboratory built into a mountainside, to a fortress where the geometry of the entrance was itself the primary weapon. Northern Peru, Amazonas region, 3,000 meters above sea level, rising from a narrow mountaintop ridge above cloud forest. A fortress wall 20 meters high and 600 meters long, constructed from fitted stone without mortar and containing, by engineering estimate, more total material volume than the Great Pyramid of Giza. Kuelap, built by the Chachapoya people across a construction period spanning the 6th through the 16th centuries AD, home at its peak to several thousand inhabitants. Positioned on terrain so difficult to approach from below that the physical site itself provided decisive defensive advantage before the wall was even considered. What makes Kuelap architecturally exceptional is not its scale. 3 entrances penetrate the entire perimeter, each one designed identically and none designed for convenience. Each entrance opens at the exterior as a gap of approximately 2 meters, wide enough for normal foot traffic. Then the wall faces on both sides begin to angle inward as you proceed into the passage. The corridor narrows progressively. At the deepest constriction point, before the passage opens into the interior, the walls are less than 60 centimeters apart. 60 centimeters, one person. Anyone entering Kuelap, regardless of intent, was required to pass through that 60 centimeter gap in single file, arms pressed to their sides, unable to raise a weapon effectively, unable to shield from above, unable to draw on the presence of the people immediately behind them. Defenders positioned on the wall directly above had a target zone that could not maneuver, could not fight back, could not compress into any formation that offered protection. An attacking force of thousands would be reduced by that gap to a sequential queue of exposed individuals. Military architects studying Kuelap consistently note that this entrance design anticipates principles of defensive architecture that were formalized in European military theory considerably later. The concept of a killing ground, a space architecturally designed to neutralize numerical superiority, appears in European military literature as a studied discipline in the medieval and early modern periods. Chachapoya builders had no contact with that tradition, no access to Mediterranean military design philosophy, no shared intellectual history with the theoretical frameworks from which European defensive architecture developed, independent derivation, through direct understanding of how bodies move through constrained space, how elevation advantage is maximized, and how the geometry of passage transforms military strength into fatal exposure. Who they were defending against with such specific precision remains only partially answered by current archaeological evidence, from a fortress that weaponized its own entrance to stones that started a journey and never completed it. Sacred Valley, Cusco region. On the hillside above Ollantaytambo, 6 massive pink granite monoliths stand on a partially completed temple platform, each between 50 and 100 tons, transported from the Cachicata quarry on the opposite side of the Urubamba River, across the water, through the valley, and up the hillside, approximately 6 kilometers. 6 kilometers of transport for stones weighing up to 100 tons, using ropes, wooden rollers, earthen ramps, and organized human effort at a scale that continues to challenge engineering calculation. Those 6 standing stones are not the most revealing evidence at Ollantaytambo. Scattered along the transportation corridor between the quarry and the hilltop, in the valley floor, on the lower slopes, at river crossing points, are additional blocks of the same pink granite, same material, same quality of cut, same scale, abandoned where they stopped, not placed deliberately for later retrieval, not positioned as part of an intermediate stage, stopped in transit and never moved again, left in the positions they occupied at the moment the transportation operation ceased permanently, Archaeologists call these tired stones, a technical designation for mobilized material from a construction operation that halted without completion. The standard historical explanation attributes the halt to the Spanish conquest. Conquistadors arrived in the region in the 16th century. Inca administrative authority collapsed across the empire. Ongoing construction programs stopped when the system organizing them stopped functioning. Plausible. Consistent with general historical chronology. One specific detail does not fit cleanly. During the Spanish military campaign following the capture of Cusco, Ollantaytambo was the site of one of the most significant Inca military successes of the entire resistance period. Under Manco Inca in 1536, Inca forces successfully repelled a Spanish cavalry and infantry assault, exploiting terrain, flooding the valley floor, using elevated defensive positions to defeat a force that had been militarily dominant across the region. Active military resistance, organized command structure, functioning administrative capacity. If construction halted because Inca central administration collapsed under Spanish pressure, why was work already stopped at a site where that administration was clearly still functional enough to mount a coordinated military defense? The tired stones were already in the valley before Manco Inca used the site as his headquarters. Construction had already stopped before the site became a center of organized resistance. What halted the work before the political collapse the accepted explanation requires as its cause? No surviving record answers this directly. Those stones remain in the valley, exactly where they stopped, still waiting for an explanation that accounts for all the evidence rather than most of it. From transportation routes that tell an incomplete story, to a city that remains 60% invisible to science. Apurimac region, southern Peru. Above the Apurimac River Canyon at approximately 3,000 meters, accessible only by a minimum 2-day trek through terrain with no vehicle access. A cable car project has been discussed, contested, approved, suspended, and reconsidered across more than a decade without completion. Researchers who have studied both Choquequirao and Machu Picchu describe comparable architectural quality, similar organizational complexity, and related cultural context, products of the same civilization at equivalent levels of sophistication. By certain measurements, Choquequirao is larger than Machu Picchu. 40% has been excavated. The remaining 60% lies under accumulated jungle growth and soil. Unexcavated, unknown in its full architectural extent. What the excavated portion has revealed is substantial. Ceremonial plazas organized around sightlines and cardinal orientations. Residential terracing consistent with ranked social organization. Agricultural systems integrated into the slope below the ceremonial core. Temple structures using fitted stone construction of the same quality found at the most studied Inca sites. A water management network distributing flow from natural springs through carved stone channels. Architecture demonstrating the same technical knowledge and organizational capacity as Machu Picchu. A site receiving approximately 1.5 million visitors annually and subject to continuous archaeological attention for over a century. Peru's Ministry of Culture maintains restricted access beyond the established visitor path. Independent excavation permits are rarely approved. Official excavation activity has progressed at a rate that most observers would characterize as slow relative to the documented significance of the location. Stated reasons: conservation priorities, resource constraints, logistical complexity, are legitimate considerations in archaeological management. Also true, a site comparable in scale and quality to one of the most studied archaeological destinations on Earth has remained 60% unexplored for decades. The unexcavated majority is statistically as likely to yield significant findings as the portion that has already produced them. What lies under that jungle has been there for 5 centuries. It is not going anywhere. Whether the pace of investigation matches its documented importance is a question the current excavation rate does not easily answer in the affirmative. From a city waiting to be examined, to a pyramid that has already demonstrated something the buildings surrounding it have not. Lima, capital of Peru, population exceeding 10 million, rising from the middle of the Miraflores district, surrounded by apartment towers, commercial buildings, and urban infrastructure, stands a pyramid, Huaca Pucllana, constructed by the Lima culture approximately 1,500 years ago, rising 22 meters, occupying a footprint of several hectares in one of the most valuable urban zones in the country. Lima sits on the Pacific Ring of Fire. Subduction of the Nazca Plate beneath the South American plate generates seismic activity along the Peruvian coast with regularity and intensity that has shaped construction requirements in this region for as long as people have built here. Major earthquakes struck Lima in 1687, 1746, 1940, 1966, 1974, and at intervals since. Reinforced concrete buildings designed to contemporary seismic codes have required reconstruction or significant repair following major events. Colonial and older structures have fared worse. Huaca Pucllana has not required reconstruction. Engineering analysis of the pyramid's interior identified a construction method researchers named the bookshelf technique. Rather than a solid core of packed earth or rubble, the interior consists of millions of small adobe bricks, each oriented vertically on its narrow edge, arranged in parallel rows extending through the structure. Between each row, a deliberate gap, present in the original construction, not accidental, not the result of settling or deterioration. Understanding those gaps requires understanding how seismic energy moves through structures. Ground motion transmits energy in compression and expansion waves traveling through a building's material simultaneously. Rigid structures resist this energy directly, initially effective, but as wave cycles accumulate, stress concentrates at structural weak points until resistance fails catastrophically. Flexible structures respond differently. Controlled movement through the structure dissipates energy across the whole rather than concentrating it at specific failure points. The structure absorbs rather than resists, bends rather than breaks, and the energy passes through without reaching the threshold of irreversible damage. The gaps between bookshelf rows create precisely this flexibility. Under seismic loading, the rows of upright bricks move slightly relative to each other, absorbing wave energy, distributing it, preventing concentration. The structure experiences controlled small deformation rather than catastrophic failure. Base isolation, energy distribution through designed flexibility, controlled structural response to dynamic loading. These are the organizing principles of contemporary seismic engineering, developed over the 20th century, refined through analysis of earthquake damage patterns, now applied in the design of buildings intended to survive major seismic events. Applied at Huaca Pucllana approximately 15 centuries earlier, in adobe brick, at urban scale, in an environment that has provided repeated empirical confirmation across a millennium and a half of actual earthquake. The pyramid is still standing. Buildings around it, designed with the accumulated knowledge of contemporary structural engineering, constructed from precisely specified materials, built to codes developed explicitly for this seismic environment, have required reconstruction. The knowledge existed. It was demonstrably correct. It was encoded in a structure built when the Roman Empire was still standing. For most of the period since, nobody asked why it was still standing while other things were not. 7 places in Peru. 7 engineering achievements that predated the formal knowledge required to produce them. Caral, a city 5,000 years old, dismissed for 3 decades because its existence required revising foundational assumptions about how civilization develops. Ruth Shady spent 30 years establishing that what she found was what it appeared to be. The Huaca Pucllana, a wind-powered hydraulic network operational for 15 centuries in one of Earth's driest environments, whose operating principle went unrecognized by researchers until satellite imaging was applied in 2016. Moray, an agricultural facility generating 17 distinct microclimates within a single structure, used to sustain 12 million people across extreme Andean terrain, operating centuries before controlled experimental methodology existed in any formal sense. Kuelap, a fortress whose entrance geometry reduced any attacking force to a single-file target queue, anticipating defensive architecture principles that European military theory would not articulate for centuries. Ollantaytambo, a construction site with 6 stones successfully placed and dozens more abandoned mid-journey, with an official explanation that does not account for when the work actually stopped relative to the events it cites as cause. Choquequirao, comparable in scale and quality to Machu Picchu, 60% unexcavated, with access restrictions maintaining that percentage across decades. Huaca Pucllana, a pyramid that has survived every earthquake to strike Lima for 1,500 years, built using energy distribution principles that structural science formalized in the 20th century, standing in a city where more recently constructed buildings have required reconstruction. One pattern connects all seven. Knowledge, precise, functional, demonstrably correct, existed in these places before the intellectual traditions we credit with discovering it had developed it elsewhere. Hydraulic engineering, agricultural science, military architecture, seismic engineering, urban organization, all present in Peru, all operational, all still functioning in some cases today. The institutional response has been consistent across academic disciplines and government agencies. Slow acknowledgement, extended dispute before confirmation, restricted access to sites not yet fully examined, official explanations addressing most evidence while leaving specific details unresolved, excavation rates at significant locations that do not match their documented importance. None of this is conspiracy. All of it reflects something more straightforward, and in some ways more significant. Institutions confirm what they already believe. Evidence requiring revision of foundational assumptions moves through those institutions at the pace humans can manage to revise their understanding. That pace is human, understandable, but it has a cost. 30 years of Ruth Shady's career represents that cost in one case. The tired stones at Ollantaytambo represent an open question. 3 decades of research has not closed. The 60% of Choquequirao beneath the jungle represents knowledge inaccessible, not because it does not exist, but because the rate of investigation has not matched the rate at which it could be known. The knowledge in these 7 places was not produced by accident. Someone understood Nazca wind patterns precisely enough to design a system moving water without pumps across 15 centuries. Someone understood Andean temperature gradients precisely enough to engineer 17 growing environments within a single structure. Someone understood seismic energy distribution precisely enough to build a pyramid that has outlasted every earthquake to strike its location for a millennium and a half. That knowledge came from somewhere. Understanding it, applying it, encoding it in stone and adobe brick in forms demonstrating their correctness by continuing to function. Present, in the stone and the bricks and the spiral holes cut into desert earth, waiting for someone to look carefully enough and honest enough to say what they found. If this is the kind of history you want to keep following, Enigma Science exists for exactly this reason. Discover the world with us. Subscribe.